So, welcome. Project Greenskin, ground support bush aircraft for North Force troops which are in the Northern Territory and far north West Australia. North Force are a reservist group in Northern Territory, Western Australia. They essentially, they're reservists and it's mainly made up of Indigenous Australians. The unique thing about North Force is that they have a very large surface space they have to encapsulate. So about 1.8 million square kilometres they have to service in terms of surveillance, operations, reconnaissance and slight fortification as well. In the world, it is the largest area of operations for any military unit. The problem exists at the moment is that there's no aerial support, whether it be for food, for emergency, for equipment. They have no aerial backup. So we were tasked with the operation of servicing them potentially if there's an emergency, to drop food parcels, to drop any kind of equipment, and also potentially in conflict. So we went through and went right back to the fundamentals and thought, okay, so what does this mission really require? What does it encapsulate? So we broke it down and we thought, okay, well, we want this aircraft to be able to drop food parcels, we want it to be able to drop water, and any kind of equipment or ammunition if there's any kind of need in terms of emergency. So coming back to the basics, every single engineering decision that we made, we always went through and we said, okay, well, what does the mission require? What do we really need to do to fulfill our requirements? We went through and North Force actually really exists. So we went on the website, we went and spoke to industry professionals and said, all right, where are the main bases existing for North Force? And we found them, and these are the main North Force bases, and this is largely where there are airstrips too. So we went through and we were like, okay, so we need to determine a radius. How far do we need to fly to go out to service these North Force troops? So we defined a radius, and then that fed into defining our specifications and requirements. The first requirement was we wanted to drop about 200 kilograms of cargo. We broke that down into specifically what that means for each battalion and how much water every troop needs in case of emergency. We also went through optional requirements. We went through and we said, okay, well, what's the maximum range that this aircraft needs to service? 700 nautical miles. Short field takeoff, very important. There are a lot of bush strips out there. There are a lot of unsealed runways out there, so we have to service those too. So obviously the aircraft needs to be able to do that. And we met all of those requirements. So James, a brief outline about how we broke down the cargo.
Yeah, thank you, Marco. As we can see from the video, the primary mission of the Greenskin aircraft is to drop payload, which means food, water, medical supply, and maybe ammunition to extend the operation hours of the ground troops. Research was initially conducted to investigate the amount of food and water our soldiers can take per day and how much they can carry during operation. The team has agreed that the payload should be dropped in small packages so that the soldiers can just take and go on the spot. The figure shows the payload breakdown for each package, which have a combination of food, water, and medical supply. A normal cargo weight will be estimated as 120 kilograms, which can supply a section of the North Force Battalion for 5 days. As a cargo aircraft, we kept a close eye on the weight and balance of the Greenskin aircraft. We make sure that there's no balancing issues before drop, after drop, or in any flight conditions. After we defined the payload, we went on to design the aircraft. The first stage was the initial sketch phase. We came up with a few configurations, and the figure shows the chosen one. The team has agreed that the design should be mission-driven, and the most suitable design is the highway design with the payload underneath. This gives us several advantages as it facilitates the ease of loading and unloading of the payload, and it also minimizes the aircraft weight as there's less wasted space. Then we proceed to phase 2, the CAT modeling of the Greenskin aircraft by using CATIA V5. The modern CAT system offers the most efficient and natural way to represent the complex mechanical structure. CATIA was heavily used to generate the geometrical and the structural model to refine the concept sketches. Later on, after we got the CATIA model, simulations such as CFD, X-plane, and wind tunnel testing was conducted to validate our assumptions and our hand calculations. This will be further discussed in our presentation. So from the design perspective, modification has been done throughout the project, and after a few iterations, the finalized version of the Greenskin aircraft was proven to give the best performance for our mission.
Thank you, James. Next up, we talked about some design considerations we went throughout the project. Number one was visibility. As James mentioned before, the aircraft is a high-wing configuration, We understand that this can create problems in terms of visibility for the pilot as he's sitting behind the wing. So we decided as a team that the aircraft will be flying by VFR, which is visual flight rules, mainly because bush trips will not be, they won't have facilities in terms of instrument landing. Therefore, it was a main concern and it was a main consideration that the visibility of the pilot from the cockpit would be very good. This figure shows the current visibility from the final version of the plane. Next up, we have structures. As a team, we decided that the fuselage of the aircraft will be a truss frame structure, as shown in the picture. I know it's a little dark, but it's a truss frame structure mainly because the aircraft will be flying in rough terrains. We had to take into consideration damage tolerance, and if there is a time of war, the aircraft will be a potential target. Another consideration was that because we'll be flying at altitudes that do not require a pressurized cabin, we did not opt for a stress skin structure. Next up, the controls of the aircraft. We decided to go for a control stick mainly because using the control yoke, as Manu is showing us, will have in an inclined posture. It will require the pilot to have his hands very straight, very rigid. This can cause fatigue. Therefore, we opted for a control stick, which Manu is describing for us, which will be much easier to handle in case he's flying for long hours. And another thing is that it is much easier to maneuver the aircraft when he's required to use only one hand. Next up, I've got Pratik, who will be talking about some aircraft specifications.
Well, as engineers, we love numbers, and throughout the program, we were able to derive a series of numbers that will help us accomplish our mission. But if I was to give you all the numbers right now, it will take me ages, so I don't want to waste your time. I'll just talk about some of the critical specs which we believe help us achieve our mission. As everyone's been saying so far, the aircraft should have been able to take off on a short distance. What we found was the shortest runway in Northern Australia is 580 meters, and the aircraft was designed to take off in some distance less than that. Then, once it takes off, it will climb to a cruising altitude of 9,000 feet, cruise efficiently at 172 knots, drop the payload mid-flight, and then return to base. In other cases, the aircraft can fly on a full tank for 4 hours, where it can be used for surveillance missions. Next important thing would be the center of gravity. The aircraft is a cargo aircraft, so we had to make sure that the aircraft is loaded in multiple configurations. So we can have payload from 0 to 200. The next part is the landing gear. The aircraft will be operating in harsh conditions, so the landing gear should be able to take those harsh conditions. The tire pressure and the size was decided such that the aircraft can land on sand if required. The aircraft is powered by a 500 horsepower turboprop engine, and my friend Maxwell will give you all the details.
Thank you, Pratik. Okay, so another important design consideration was the engine selection. So the team collectively chose to use the PT6A112, which is a turbo propeller engine. And it wasn't a matter of just finding an engine on the market and just whacking into our Greenskin aircraft. We had to look at how it was going to be used, what it was going to be used for, and where it was going to be used. So location and environment. And by selecting the engine based on these criteria, we're able to have significant costs on maintenance, significant savings on maintenance costs, and we're also going to have significant advantages. So considering advantages, maintenance. Because it's a turboprop engine, the PD6A112, it's a lot more smooth running. Its vibration less. It's got less vibration than a conventional piston propeller engine, and as such, it'll have a significant impact on the fatigue life of components. So Covington in 2011 did a paper. He also suggests that a turbo propeller engine has more prolonged TVO as compared to a conventional piston prop engine. So as such, the PD6A112 was advantageous in that aspect. In terms of performance, our aircraft needed sufficient maneuverability. It required short takeoff, which is what Marco has talked about. And again, the PD6A112 was able to fulfill this. In terms of range, we had a soft spec that the aircraft was to be able to fly for 700 nautical miles.
And through validation through X-Plane, which Manu and also Marco flew, the PD6A was also able to accomplish that. In terms of fueling, we had a look at the aviation fuel outlets in the rural areas that Northern Territory had, and the aviation fuels that they provided. The PD6A112 being a turboprop engine uses AVTUR, and as a result, and because it's more readily available in the rural areas of Northern Territory, this is also more convenient for those who are operating aircraft. Also, because the AVTUR is a lot less volatile than avgas, it is also safer and better to carry than avgas. And I'll now pass on to Ben, who will do the validation.
So now I'd like to talk about some of the approaches that have been made during the whole design phase to validation processes. So these include wind tunnel testings, CFD simulations, as well as X-plane flight simulations. For wind tunnel testings, before the actual testing procedures was carried out, a scaled down wind tunnel model was created and exported from CATIA, which is for the actual testings. So this is the testing model that has been used for the whole testing procedures. And then the wind tunnel testing was performed to basically measure the coefficient of lift at different angle of attack as to justify the results from all those empirical data. Some flow visualizations was also done during the wind tunnel testing phase, just to define what exactly is the critical stalling angle of the Greenskin aircraft. So in addition to that, CFD simulations was also done, just to find as an additional add-on for the validation processes. So the CFD was set up initially in a similar conditions to that of wind tunnel testings, so that processes can justify the strata. And it also proves to be a great tool for flow visualization as well, as a streamlined flow field can be clearly seen from the post-analysis. So as you can see from the figures, the Greenskin aircraft stalls around 14 degrees angle of attack, which somehow correlates to the theoretical estimation as well. So furthermore, X-plane simulations was also used as an alternative for the justification. Which is, you can see from this chart, all approaches shows consistencies, and the result tends to conform to one another. So for additional further information about X-plane simulations, I'll now hand it over to Maggie for further elaboration.
Okay, before I continue my presentation, show of hands, who knows how X-plane can help you? Help us see aircraft. See a number of hands there. Okay, most of you didn't know. Okay, for the benefit of those who don't know, we have already prepared a few slides about X-plane. X-plane can be used to find design solutions. For example, we use X-plane to size our control surfaces. And each time we size our control surfaces, we had experienced pilot, Marco, who will test. Yeah.
So we went through and we tested, we validated all of the results in X-plane, and we also put the aircraft through a number of different testing parameters. We also ran it through the GFT flight syllabus as well, GFPT flight syllabus. So not only did we do that, but we also did extreme crosswind landings. We did sort of tailwind takeoffs, things that you wouldn't get in real life situations, just to see how the aircraft would behave, and it handled as expected. We did a lot of steep turns, we did a lot of stalling. We even flew VFR in sort of reduced visibility to see how the aircraft would end. So it behaved as expected, which was great.
So that's a little Okay. X-plane can also be used to find the takeoff distance. For example, we simulate our aircraft under different ground conditions, and after we simulate to find our fuel tank required for different ground conditions, and after that we validate against hand calculations. X-plane can also help us in design visualization, such as the cockpit layout. I'll hand over to Veronica to come on with us.
So our Greenskin aircraft is equipped with traditional analog dials, as we can see here. To start our design process for the cockpit, we consulted the FAR 23 regulations in order to compile a list of the minimum required instruments for our turbine aircraft. We also considered unique features to our mission, such as a button to operate the cargo door for in-flight procedures. As was mentioned previously, our aircraft is flying under visual flight rules, So to assist, our aircraft is equipped with GPS. The Garmin G725 has been chosen for this and shall be mounted to the flight deck. Once we had a list compiled of all the instruments required, we used sketches, then CATIA and X-Plane in order to come up with our configuration. Today we see a trend with light aircraft to be either built or retrofitted with glass cockpits, and we've taken this into consideration and shall supply the Garmin G500 as an optional extra on our aircraft. When the cost-benefit analysis was carried out, the quoted price of $20,000 was not justifiable to use the glass cockpit as our standard configuration. Ivan will now go into cost in more detail.
As Veronica just explained, Garmin G500 is an optional extra for the Greenskin aircraft. We also plan for other optional extras to be determined based on the market needs, which will be determined at a later date. The standard Greenskin aircraft is currently priced at $850,000 Australian dollars. To determine this, we had a look at the operating cost per year for the Greenskin aircraft. We found that $470,000 is required to operate the Greenskin aircraft per year. This included $260,000 in direct operating costs, $130,000 in indirect operating costs, and we also included $80,000 for allowances in engineering reinvestment and interest payments. We evaluate the Greenskin aircraft at approximately $1.4 million. This is based on alternative savings in admin, personnel, and transportation at $620,000 per year. We then had a look at the market. We determined apart from the primary Norforce market, the aircraft can also be used for border and territorial disputes, as well as combating drug producing and trafficking. From this, we identified two key markets. The first one in the Asia-Pacific region, including Australia, India, Pakistan, and China, and the other one in South America, including Brazil, Colombia, and Venezuela. From this, we broke down the Greenskin aircraft into three major components: the airframe, the engine, and the systems. We then broke down the aircraft into further smaller components to find the price of individual components. We found that approximately $1 million is required to manufacture one Greenskin aircraft. That reduces to $850,000 for producing 24 aircraft, and further reduces to $720,000 for producing 56 or more aircrafts.
So today we are able to proudly present to you the Greenskin aircraft, but there's still some work to do and some time before we see it in our skies and protecting our borders. There will be consultations with industry in order to make technical improvements to ensure that our aircraft is at the highest standard. In addition, there shall be a market consultation phase whereby markets other than Norforce shall be consulted and investigated and configurations made for them. In doing this, specific operating considerations shall be made. So we thank you for your attention today, and we now open an invitation for any questions.
What's the tide pressure that you have?
It's around 23 psi. The mean length is around 3.
Great.
I think largely okay. We did do a number of tests, calculations.
Well, in terms of calculations, we graphed out the different times of the payload drop at approximately 75%, 50%, and 25% of the fuel. That way we knew what the change of the CG location would be in terms of when we drop the payload. From there, we then did a few iterations to find out where we can place the payload for minimum changes in the CG position.
There was a little back and forth, so we ran that into X-Plane, we tried it, and then we put it back, and then we did some more trial and error, so it was like a thing for the results.
This one is a very good presentation. Like the previous one, did you consider mission? So there are existing aircraft out there that that have proven themselves, and then one by second hand were launching. So yeah, don't consider pricing as supporting the law competition.
We did have a look. One of the key things is that there is a new aircraft developed by Africa, which is for a similar purpose in terms of surveillance and ground support. This is why we didn't choose that market as one of our primary markets. In terms of older aircraft which can be used for similar purpose, they're not exactly designed for this specific small payload dropping capabilities, where our aircraft can be used for specifically that purpose and is designed for that purpose. That way we know that this aircraft is the best aircraft for that purpose.
Right, but you see, when you do an investment like that, you don't have to use a system like that, so you just don't design system.
That's true. That's why that's part of our next step, where we consult other markets in terms of optimizing and configuring the purpose
to their needs.
Did you consider what the ADF would expect to see in an aircraft? I mean, it's a good presentation, but you open the door to the question of combat operations, which I think will probably stay with me. So, did you consider armour, self-defence systems, communications links with respect to flight defence?
Well, in terms of like attaching arms on the plane, we do have pipeline of the wings in case
That's armour.
Armor is in the unit.
Because you raised the topic of using a range.
I believe that this is because I'm a soldier in Singapore. I served for 2 years, and in Air Force there's this participation command. Means that people work together. It's not like just armor by itself, and Air Force then they are separate units.
So I mean, Kevlar plate.
Oh, armor.
We didn't actually consider this. This was outside the scope of our plane. The piloting conditions we expect for reservist troops. That way we will not be putting the reservist troops in that sort of conditions in the basic life of the aircraft.
So it's not for use in a contested environment.
It's not really clear, yeah. It's designed, primarily designed for peacekeeping missions, but it is capable of only some guns for ground support, but not in combat situations, so we've done that.
Just be aware that hundreds of kilograms of ADF specific communications equipment, health and safety club.
So you talked about the airdrops, as I said, not past there first, for life support systems. What factors did you consider in such a large glass cockpit in terms of bird strings, which, especially in the Northern Territory areas?
Well, the Greenskin aircraft, when operating in the Northern Territory, we're not going to have the glass cockpit. That was mainly for other markets who may want to have it. But as a standard cockpit, we're just using the analog instruments.
How did you determine the initial sizing?
We initially sized it based for the horizontal tailplane. We initially sized it determining by the center of gravity location, and we assumed horizontal tail volume ratio. That was our first step. From there, we optimized it based on the neutral point and the forward CG limit, which is based on the rotation during takeoff. By optimizing the size, by changing the size of the tailplane, we can then move the range of the CG to what we wanted to. So one of our primary goals was to have the CG location of the payload to be highly configurable. That was one of the main considerations for a horizontal tailplane. For the vertical tailplane, our initial estimate was also based on a vertical tail volume ratio. However, we then further optimized it based on crosswind during cruise and crosswind landings.
Quick comments. One of the traditional problems with those sorts of aircraft on rough strips is propeller maintenance. So we hear that you've got very little ground clearance on the propellers there, particularly with that flat nose or the deflation strut. You might find the tail drags better, but the other thing I noticed is the visibility from the pilot is sort of cool. As soon as you rotate the nose to take off, you can lose sight of the surroundings. Maybe come back to something like a Transat aircraft.
For the current problem, we looked into the current problem. We looked into the regulations, and then our propeller fits the regulations. So I think that that's fixed, or we can consider that in our project.
Tail dragger is also a good comment. We did initially look at that. I think the first design iteration, the drawing actually had a tail dragger on it. But because you're actually loading cargo into the cargo door underneath, we found there were challenges with having a tail dragger and loading cargo underneath. So that's part of the reason why we tried to. But yeah, having gravel and stuff flick up and propeller and cause cracks and things, that's something that we're definitely cognizant of.
Good presentation. I know we're engineers, we do lots of numbers. Weights and stall speed and high lift devices, that kind of stuff. You're talking about short field performance.
Yeah.
How about the numbers?
Sure. If you take off within 580 meters, which is the shortest strip in Australia, it has slot flaps which will be deployed at 10 degrees on takeoff to provide that extra lift. And anything else?
What sort of stall speed?
Stall speed gets to be regulated to FAR 23, which is 60 knots.
That's what the regulations say. What does your simulation say?
Simulations.
For simulation, we got about 65 knots.
Okay. In what configuration?
20% flex.
Okay, that's the landing configuration?
Yeah.
Okay. Well, that's above the 61 knots that you're allowed in FAR 23.
Yeah.
FAR 23 says school split landing configuration 61 knots or less.
Yeah.
So we're going to do about 4 knots.
So,
adjustment.
yeah, but that's with the clean.
That's clean, isn't it?
Clean. So 64, not 65. What you meant was with clean. Once we deploy the flaps, it is within regulations. And
What is it?
down to about 60 knots exactly. 60 knots when you're taking off, and about 58 knots when you're landing.
Okay. And what's the maximum takeoff flight?
Maximum 1780 kilograms. 1780 kilograms. Takeoff.
Just to make one further comment, this is a single-purpose aircraft for about $1 million. Right? You'd want to have a good salesman to convince me that I wouldn't want to buy a separate caravan with the same engine.
One thing we can differentiate is it's a very modifiable aircraft. So what we've tried to achieve is a very simple and basic layout. This is very modifiable.
But
It's
not
got
modifiable
hard
for 10
points.
seats.
Sorry, sir.
It's not modifiable for 10 seats. What I'm saying is if you I know it's designed as a simple purpose aircraft. Look where it fits in the scheme of things. Though there are other aircraft out there that have more flexibility that will achieve the same mission.
Cessna Caravan can, what we tried to do was design an aircraft which Northcoast was used, which then can be modified to be used in further markets. And I guess that was the answer, and we did achieve that.
I think one of the other things that you should state was you intend having aperture pilot. You had a reservist pilot.
Yes, that's right.
So
It's
it would be a handful for a caravan, a handful for a reservist pilot.
Which answers your question as well, why is it not being used in combat situations? Because what we're trying to do is, the aircraft should be explored, we should be able to fly. Any reserve pilot should be able to fly the aircraft.
So that's very simplistic controls. It's not.
I don't think you'll find a much simpler airplane to fly than Cessna Caravan. One thing I would stress in your sales training, though, is environmental control in the cockpit. A big canopy like that brought Australians having their tries to do. We might put air conditioning in very large letters somewhere.
Did you do a study of how much stress, because I guess you said that you were not going to have any stress schemes. Yeah. Is there a penalty for not doing that on the wings?
Yeah.
Is that actually tubular construction?
So let me just clarify. The no stress skin is mainly for the fuselage in order to maintain flight. For the skin, we do expect some kind of stress. That's as expected. But from that, we have included that in design for the wing specifically.
What cost does the site engineers design up some sort of composite?
Mostly, sir, it's supposed to be operated in very harsh conditions, and so in our parametric research, we were never able to find an aircraft with carbon fiber and all the new technology being used in the bush area. So we decided to stick with braces and use steel frame structure for the fuselage?
The skinners are really mainly because in terms of maintenance, there wouldn't be skilled technicians available in those rural areas that would be equipment to maintain a carbon fiber skin plane. So that's why we didn't consider it, but in terms of maintenance, it would have been too costly.
So a steel frame in that environment would have its own challenge.
It's a bit heavier, but it's
It's
more
rust.
yeah.
The whole exercise is a trade-off.
Great.